Greeting everyone. Welcome to today's presentation. QSAN Qreplica 3.0 offers both synchronous and asynchronous replication solutions, simplifying disaster recovery orchestration across QSAN platforms. This seminar will delve into the concepts and detailed procedures of synchronous and asynchronous replication to ensure optimal DR practices on the QSAN platform. DR aims to prevent total failure of critical business systems, ensuring a swift recovery with minimal impact. Achieving this requires a continuous data protection approach, addressing potential challenges like human error, software-hardware failures, network issues, power outages, and more. To overcome these obstacles, IT managers should strategize redundancy with backup systems in different locations, involving regular data duplication to diverse infrastructures for uninterrupted business continuity. RPO and RTO are critical parameters in disaster recovery, guiding companies in choosing the best data backup plan for continuous data protection. RPO represents the maximum tolerated data loss and depends on data recovery update levels, influenced by backup frequency. Increasing backup frequency enhances RPO, reflecting data integrity. RTO as the system's allowable service interruption duration. A lower RTO indicates a stronger data recovery capability. Achieving a minimal RTO requires significant investment in deploying multiple disaster recovery systems. Smaller values for both RPO and RTO effectively shorten the transition from business interruption to normalcy. These indicators highlight the importance of proactive measures before and after a failure, ensuring swift recovery and business continuity. Traditional backup methods, tape or disk-to-disk, take hours or even days to recover. In contrast, disaster recovery techniques like asynchronous replication have recovery times in minutes, providing quick restoration in case of accidents. For more stringent business continuity goals, measured in seconds with no data loss, synchronous replication technology is effective. Asynchronous replication is a block-level differential remote volume backup function through LAN or WAN. In the beginning, replication will copy all data from the source volume to the target. It is also called a full replication. After that, use snapshot technology to perform incremental replication. Asynchronous replication uses the SCSI function to establish a replication connection. It can use the full bandwidth of the allocated network port to achieve the best backup speed. However, in order to balance replication traffic and non-replication traffic, the traffic shaping function can help reserve the necessary bandwidth for non-replication I/O. Asynchronous replication can achieve the same data protection goals. However, the method and frequency of data replication are different from synchronous replication. Asynchronous replication commits writes at the source and then sends the acknowledgement to the application on the host. The accumulated writes committed on the source volume will be copied to the target volume in batches at scheduled intervals. Synchronous replication is a block-level volume backup function through LAN or WAN. It is a timely replication function that can always synchronize source and target data. It uses a SCSI function to establish a replication connection. The replication task can use the full bandwidth of the assigned network port to allow the best backup speed. We assume that the synchronization source port must be greater than or equal to 10 Gbps to ensure normal operation. However, the synchronization source port in the source storage is not limited to the dedicated one. In order to balance replication traffic, it is still recommended to separate the port of incoming data from the host and the synchronization source port to the target storage. Synchronous replication can ensure data consistency between the replication source and target. This can be achieved by ensuring that every write I/O requested from the applications on the host will be completed after the host obtains the confirmation between the source and the target. If the write I/O cannot be committed on the source or target, the write operation will not be committed to ensure consistency. In addition, write failures are sent back to its applications on the host. Then, application error handling will determine the next appropriate step for the pending transaction. 1. The application on the host sends a write request to the source volume. 2. The write I/O copies to the target volume. 3. The write I/O at the target is committed to the target volume. 4. The write commit at the target is confirmed back to the source. 5. The write I/O is committed to the source volume. 6. Finally, the write acknowledgement will be sent to the application on the host. When a user creates a synchronous replication task, it will automatically copy all data from the source volume to the target at the beginning. This is also called full replication. At the same time, the source system will record a fracture log to maintain the block whether has been synchronized. The fracture log is a bitmap saved in the source storage to indicate which block of the source have been updated. It is invoked when the target of a replication connection is lost for any reason and becomes out of sync. For example, when an incident such as a network interruption occurs, the source cannot replicate the data to the target. I/O from the host will continue to be written to source. The fracture log is kept update until the incident is resolved. The source will learn about the unsynchronized blocks and replicate them to the synchronized state. If a network error still occurs and the replication is blocked, the system will issue a warning every 20 seconds and enter the failed state after 60 seconds. Therefore, the task will be stopped. At this point, if you want to continue the task, you must start it manually. Another operation is that the user can manually stop the task until the user manually resumes the task. The situation is the same. If you are not sure whether the target has been touched, you can also perform a full replication first when restarting the task. Both synchronous and asynchronous replications have their advantages and disadvantages. Before choosing a backup method, you must understand the risks of disaster recovery. Synchronous replication ensures that every data written to storage is saved locally and remotely. This can ensure zero data loss in the event of a disaster. So RPO is zero. In a synchronous replication solution, there are also trade-offs. Since each write needs to be saved locally and remotely, any problems affecting the source or target storage, or the replication link between these two, will affect the application in terms of latency and availability. As the distance between the source and target increases, this response time also increases. It is recommended to ensure that the link delay between the source and target is less than 10 milliseconds. The converted distance is about 100 kilometers. Synchronous replication is mainly used for mission-critical applications that require instant failover when the source site fails. Although synchronous replication is usually used for disaster recovery, it is preferred for applications that cannot tolerate data loss and have a short recovery time. Asynchronous replication is mainly used to replicate data over long distances. It does not affect host I/O latency, because once host writes are saved to the source storage, they are acknowledged. Since write operations are not immediately copied to the target, all writes will be tracked on the source. This data will be copied during the next synchronization. Therefore, RPO should be an acceptable amount of data, which may be lost due to failure. And RTO is equal to the period of the next synchronization. This time increment also affects the amount of data that needs to be replicated during the next synchronization and the amount of potential data loss in the event of a disaster. Of course, the perfect solution is that both RTO and RPO are zero. This means that when a fault occurs, the system will respond immediately, and there will be no data loss. To achieve this goal, the system design is extremely complicated, and the cost is very expensive. So, it should avoid falling into the vicious circle of simply pursuing the improvement of the two indicators and combining the actual situation, appropriately improving the two indicators according to local conditions, as the right way. The following summarizes the firmware versions supported by Qreplica 3.0, including synchronous and asynchronous replication. This section describes remote replication prerequisites. First, list the parameters of remote replication. The maximum replication task quantity per volume is 1, and the maximum replication task quantity per system is 32, which including both synchronous and asynchronous replication tasks. Click the plus icon in the Protection Groups pane to pop up a wizard. Select source volumes, and then click the button to move them from the left side to the right side. Click the next button to continue. Click the Enable Text link in the Remote pane to enable the replication plan. Select the mode as synchronous and select the deployment method as auto. Click the next button to continue. If there is no license enabled, the synchronization option is not visible. If necessary, select the source port or leave it as auto. Log into the management port of the target unit. Enter the remote IP address of the target management port. Enter the username and password of the target administrator account. Click the Apply button to finish the replication plan, remote configuration. Back to main screen of the wizard. Click the Apply button to create a replication task. There is a result page. Click the Close button to close the wizard. Done. A protection group with synchronous replication task has been created. First, this feature is license required. You can submit our trial license for 30 days to experience the higher performance by this function. The traffic shaping function can help reserve the necessary bandwidth for non-replication I/O operations. 8 shaping groups can be set. In each shaping group, peak and off-peak time slots are provided for different bandwidths. In the remote replication scenario, we support MPIO and MCS in remote replication. Usually, the remote replication task runs on the master controller, usually CTRL1, of the source unit. The data is replicated from the master controller of source unit to the target unit, and the target unit is set with the target IP address, usually also CTRL1, when creating the remote replication task. The second path from the source unit can be added to the CTRL2 of the target unit. The maximum MPIO in a remote replication task is 2 paths. We discuss the various replication solutions. Configuring a data protection solution helps prevent unexpected situations, such as data loss. We provide local and remote data protection solutions to help easily recover in the event of a disaster. By using both synchronous and asynchronous replication solutions, data protection can be configured to meet the needs of enterprises. Synchronous replication usually writes data to source unit and replicas at the same time. In this way, the primary copy and the replica are always in sync. In the event of a disaster, synchronous replication can provide maximum protection and ensure zero data loss. Asynchronous replication first writes the data to the source unit and then copies the data to the replica, so there will be a certain delay in copying the data to the target unit. Asynchronous replication utilizes the snapshot technology to provide a consistent point-in-time copy that can be used in the event of a disaster. When using asynchronous replication, there will be no impact on host I/O, because data will not be replicated when it enters the system. When data needs to be replicated over long distances, asynchronous replication can meet the needs of the enterprise.